for introduction. My name is Marcin Bau. I'm from Salomanus. Today I will give you a brief introduction about IP over DWDM technology. First of all, who is Salomanus? Because we attend this event first time. Salomanus is a Polish company with more than 20 years experience on the market. We are focused on the optical transmission, starting from the short distance and up to long distance, and also ultra long haul using existing or new DWDM systems. So this is our field of expertise. In today's presentation, first of all, I will put a brief introduction about technology. Then I will go to some examples where we could use the WDM solution. Later I will show the particular product, and we will discuss a little bit about the challenges and opportunities regarding to that, and then if we have time, Q&A. If not, then I will introduce you to our booth outside so we could continue discussion there. So basically, the concept of IP over DWDM is pretty old. It exists on the market already around 20 years. It was pretty well developed with 1G and 10G optics. But the point is that later we have difficulties with migrating to 100G and 200G, 400G technology, mainly because of the size of the transceiver. Because the coherent transceiver accepting that technology, we're using the CFP, CFP2 interfaces, and we don't have such interfaces in our routers and switches. So basically that was the difficulties, and the implementation of IP over DWDM was not possible. Basic idea of implementation is that we just remove the two local connection and transponder, and we put the color transceiver directly into router and switch. So in general, because of that idea, we are able to save around 50% of the investment cost, and even up to 80–90% of the maintenance cost. So this is basically why these topics become hot now, especially with new interface like USFP28 and USFP-DD supporting that technology. But there is not only DWDM, there is also more technology there, which we could use. Basically, as the IP over WDM depends on what distance you would like to achieve. So what we have here is like full band of CWDM. You know that there is 18 channels here, but among that channels, we could also use some all-band technology. This technology is pretty interesting because it's supporting 100G speed per wavelength and could run up to 30 km without any amplification. So this is really great opportunity when we need to migrate to 100G with a local some access network. DWDM technology is located in the C-band. We have plenty of channels here depending on the what grid we choose, 50 GHz, 75, 100 GHz, or flex grid. We could have plenty of channels adjusted to what we need. Now we'll jump into a few examples of the network. So basically, this is the real network we deploy for few of our customers. This is not one of our customers. Customers basically are ISP. So there is few ISP which were located between two big cities with internet exchange point. And to be independent from the network operator, the tier 1 or tier 2, they decided to rent, in this particular case, they rent single fiber, but you could also go with dual fiber technology, it depends on you. So they rent the fiber from city where was the first internet exchange point and the city where was the second internet exchange point, and they built using that fiber only WDM system. At the day first, they used 10G connection to both neighborhood cities, and because all infrastructure in the middle is completely passive, so they were completely independent. The advantage of that technology is that even if we decided to build it like that, we could easily upgrade it in the future. So if we need more channels, and we take it into account while building our network, we could easily add another wavelength, even with speed 100G or 400G. It all depends on our needs. And the very important is that the cost we will have will be fixed no matter how many wavelengths we will run, because our fixed cost will be just leasing the fiber. All other is the investment. Other example of the using of WDM network is, I think that's even less obvious. I name it switch or multiplexer. Usually when we build the access network for business or enterprise customer, we are using the topology that we have our core node. Closer to the customer, we build the aggregation node. And then at the customer premises, we give customer different CPE equipment. And usually we cascade. In my example, I use the first link 10G connection to the aggregation switch. And then as a CPE, I use 1G. Of course, we could have here 100G and like a few 10G here. But the point is that, in fact, we don't need active equipment here. Active equipment here is guaranteed power. We need to provide to make it up and running even if there will be any power cut. We need a dedicated space because we need to provide the power, we need to have the access to that device. And in fact, this device could be replaced by passive multiplexer, which we could close even in the enclosure without need to the power supply. And additionally, we will have the huge benefit because each customer could be independently connected to the core node. So this is the huge advantage. So even if all customers run on the 1G and one of them asks for 10G, we don't need to replace the switch to have the in aggregation with the 40G uplink or 100G uplink to be able to provide 10G download to the customer. We just replace the CPE at the customer and two transceivers in the core node and in the access node. So this is the huge advantage of that kind of approach. And we already have a few successful implementation with the operators, like removing the switch from the aggregation nodes. There is plenty of solution that we could start, for example, from 4 channels and then in the future upgrade up to even 32 channels to also lower the investment cost at the beginning, to not invest in a costly solution. And yeah, as I said, the huge benefit is that this is completely passive and traffic independent, because traffic depends on the optics you will install in the CPE and the core node. Now I will switch to the transceiver we have available. In my presentation, I skip all the transceiver like 10G, 1G, or 25G because they are pretty popular and everyone, I think, that know pretty well them. We have the CWDM, DWDM transceiver there, and they are pretty known. Also the one with the tunable laser. So let's focus on the one with a bit higher speed. So first of all is QSFP28 O-band technology. This technology using the second window, so the wavelengths are located around 1310, and the benefits of that is that we have zero dispersion within that range. If we're talking about the standard fiber, G652, the most popular one. So because we have zero dispersion, we are able to run the 100G links without using chromatic dispersion compensator, even though we have the transceiver with the direct detect, not coherent one. So the one which helps us to save a little bit on the cost. And that transceiver are able to run up to 25-30 kilometers over the dark fiber or over the O-band WDM system. So we are able to run up to 1600G wavelengths, completely passive, using the QSFP28 directly in our switches or routers, and putting just pair of the multiplexer at the end, same as we know from the CWDM technology. The other solution a bit more complex, based on the DWDM, because with the DWDM network we have the chromatic dispersion, so we need to address that. That's why we need amplifiers and we need chromatic dispersion compensation. But the advantage of the DWDM is that we could run the distance even up to 120 kilometers. If we want to run even more, we could take a closer look to the coherent solution. Coherent solution, they are using the DSP instead of the direct detect modulation. And because of those, a lot of calculation can be done by the transceiver. So we don't need to take care about the chromatic dispersion, for example, because it could be calculated. That's why this transceiver have the ability to compensate 6,000 picoseconds, which equal 300 kilometers. And it could be also amplified many times. Because the SNR, accepted SNR level is 16 dB. So based on the experience, it could be even 1,000 kilometers of the link. What's very interesting, the QSFP28 coherent solution, they have selectable receiver. So it means that we don't really need multiplexer anymore. We could use directly even passive optical splitter to do the colorless implementation even in access node, even in access network, because the receiver will accept only particular wavelength. So this is one of the applications we could use that technology. Of course, we could use it also in the brownfield deployment when we already have existing network. If we have network which was designed for 10G links, so we have plenty of compensator and amplifiers, for sure we will be able to run longer distance. As I mentioned, 300 kilometers is the ability to compensate the power, the chromatic dispersion. But if we have 10G network, we need to usually compensate the chromatic dispersion up to 1,600 picosecond. So this will be no limitation for that transceiver. So only limitation we'll have is chromatic, is OSNR, and that level will allow us to go even 600, 800, 1,000 kilometers if we have good quality network. The other approach is QSFP-DD, and QSFP-DD is 400G transceiver. If we talk about the 400G transceiver, we need to take into account that there are two standards. One is based on OIF, which came to the market first. It's based on the DC data center needs. That's why it was designed only to carry 400G traffic and do the interconnect with the distance up to 120 kilometers. The second implementation is a bit more flexible, have much stronger forward error correction and more application. So we could run a few times 100G, we could run 200G, we could run 300G, 400G client-side traffic and carry it over the system. The transceiver itself have 0 dBm output power. This is very important because 0 dBm output power allows us to use that transceiver in the existing network. Most of the existing network have the input power, required input power on the multiplexer in the level of 0, -2, -3 dBm. Due to fact like that the CFP-based version transceiver or the built-in into the optical transponder card, they had such output power. And that transceiver allows us to use it directly with existing network. So we could easily deploy it as just installing the QSFP-DD in our router on one end of the link on the other and having in the middle any optical network, any DWDM network we have. What we need to take into account is that 400G speed require at least 75 gigahertz channel spacing. So either we need to have flex grid network, either 75 or 100 gigahertz grid network to be able to run such speed. But of course we could run that transceiver in the lower speed. So if you want to run 100G or 200G mode, we could still use 50 gigahertz grid network. That approach, so IP over DWDM approach is able to help us to address current need for the bandwidth, which is growing dramatically year by year. And you need to take into account that that technology help us not only saving the investment, but it also help us saving a lot of power consumption our devices will use, and also reduce the number of the space we will need in the data center because of no need of installing the transponder or maxponder. So it will help us to make the network more green. That's all what I prepared for today. If you have any question, please feel free.
Thank you. Sure. Round of applause, please, perhaps. Do we have any questions?
Are you staying for summer? So
Are you staying for summer?
Yes, of course.
you can ask them.
No. Okay, great. Thank you very much. We're running late, but you know that. If we could try and keep the coffee break to 10 minutes, that'd be really good. And I won't have to send Alexei after you to chase you all in. Enjoy your coffee.